will give you one formula, and the bottom signs will give you another. So if you're looking over here at the sum of cosines, if we do alpha plus beta, so that's me doing the first one right here. When you get over to this sign, you have to use the top one, which is a minus. And that's why I used a minus over here. Does that make sense? So they're giving you two formulas in one line. The other formula is the cosine of alpha minus beta. So they're doing the bottom sign. That's my second formula over here. And then they use the bottom sign plus over on that side. So I split up the sum formula for cosine and the difference formula for cosine. And I split up the sine one, but I copied the tangent one just the exact same way that they had it. I think really because I just ran out of room. Okay? So, here's why these are useful. Because now, without a calculator, we can find the cosine of 15. It's not something you have memorized. It's not something that you would have to memorize. But we can create 15 with zeros, 30s, 45s, 60s, or 90s. You can add two angles together to get that, or you can subtract two angles to get 15 using the memorized values that you know of 0, 30, 45, 60, and 90, right? So which two of those numbers will add or subtract to give you 15? 45, John said 45 minus 30. He whispered it to me, but he said it. Good job. 45 minus 30. So in order to calculate the cosine of 15, I have to think of it as the cosine of 45 minus 30. That's an okay substitution. And then I can use my difference formula up here. My alpha is 45, my beta is 30. So when I go to write this, the cosine of alpha, that's 45, times the cosine of beta, that's 30, plus the sine of alpha, which is the sine of 45, times the sine of beta, which is the sine of 30. And this is where I'm saying your memorized values are critical, because you obviously need to know them. The cosine of 45 is root 2 over 2. The cosine of 30 is root 3 over 2. The sine of 45 is root 2 over 2. The sine of 30 is 1/2. You have to know those, and you have to know them swiftly, quickly, so that you can just power through this. So now when I'm just simplifying these numbers, when I multiply these fractions, I get root 6 over 4. When I multiply these fractions, I get root 2 over 4. And they already have a common denominator, so my final answer is root 6 plus root 2, all over 4. Any questions on that? Okay, the second one, it isn't asking you for the sine of an angle or the cosine of an angle, right? It's actually giving you this side of these formulas and asking you to trace it backwards. So which one is cosine cosine plus sine sine? Cosine sum, cosine difference, sine sum, sine difference, or the tan sum or difference? It's the second one, cosine cosine plus sine sine. Correct. So if we just trace that backwards, our alpha is what, Bailey? 80. So that's going to be cosine of 80 minus, and our beta is what, Nate? 20. And now we did not individually know the cosine of 80 or the cosine of 20 to be able to evaluate that. But now going backwards, it's just the cosine of 60, and that we should just know is 1/2. Okie doke. Degrees probably a little bit easier because we're more fluent with regular numbers. When you jump down to number 3, we're trying to find the sine of 7 pi over 12. So we have to figure out what critical angles that we know add to 7 pi over 12 or subtract to 7 pi over 12. Now the critical angles in radians are obviously 0, pi over 6, pi over 4, pi over 3, and pi over 2. This is tough to also see because your denominators are all different. So if you were getting them to pi's over 12, this would be 2 pi over 12, this would be 3 pi over 12, this would be 4 pi over 12, and this would be 6 pi over 12. This is obviously 0 pi over 12. Now can we see which two will make 7, either by adding or subtracting? Andrew? These two, right? 3 pi over 12 plus 4 pi over 12. So that's a pi over 4 plus a pi over 3. So I'm going to rewrite the sine of 7 pi over 12 as the sine of pi over 4 plus pi over 3. So Connor, which formula from above am I now using? 1, 2, 3, 4, or 5? 3. So tell me what to write. Perfect. And then, knowing your values, just evaluate. So we have root 2 over 2, 1/2, root 2 over 2, root 3 over 2. So we get root 2 over 4 plus root 6 over 4, root 2 plus root 6 over 4. Sort of coincidental, right? Because it's exactly the same as what we got above. Why did that happen? Why is this one equal to this one? Why is the cosine of 15 equal to the sine of 7 pi over 12? Other than because the formulas say so. What's complements? Correct. 7 pi over 12, if you were to convert that, is actually 65 degrees. 7 times 180 over 12 will be 65. And the cosine of an angle is always going to be equal to the sine of its complement. It's a little bit hard to pick up on because one's in radians and one's in degrees, but yes, good. And Nate, how can we make 5 pi over 12? And lucky for you, I already have all my pi's over 12s over here. So how can I make 5 pi over 12? Yeah. That's 2 pi over 12. What am I going to add or subtract onto that to get 5 pi over 12? Perfect. These two added together will make 5 pi over 12, so it's a pi over 6 plus a pi over 4. So the sine of pi over 6 plus pi over 4 and lengthen that out for me, Marissa. Correct. So So we just used formula 3 again, actually, because we did addition again. And we get a half times root 2 over 2 plus root 3 over 2 root 2 over 2. Root 2 over 4 plus root 6 over 4. Well, this is too coincidental. That's not, really. That's because 5 pi over 12 is 5 times 180 over 12. 118 divided by 12 divided by 290 over 6 divided by 2, 45 over 3 divided by 3, 15 over 1. That's a 65-degree angle. Oh, then what's that? Oh, that also, so here's why. This was not a 65-degree angle. 7 times 180 over 12 isn't a 65-degree angle, it's a 115-degree angle, which means it was here, and if this is 7 pi over 12, this is 12 pi over 12, it had a reference angle of 5 pi over 12. This is just the first quadrant version, this is the second quadrant version, and since sine is positive in both of those quadrants, they ended up being the same. Okay? With these, we will still have some proving to do. We're still going to have to verify. So if you see the cosine of a sum or a difference, do not distribute cosine. You distribute numbers. You do not distribute cosine or operations. Same reason when you do the square root of 25 plus 16, you don't distribute the square root and just take the square root of each piece. That's not how operations work. You can only distribute numbers. So do not do that. That's first warning. You see the cosine of a difference, use your formula. So from above, this is going to be cosine alpha cosine beta plus sine alpha sine beta over sine alpha cosine beta. So they're just going to get a little bit longer and lengthier. Thoughts now, what can we do to the left to continue simplifying? It's a binomial divided by a monomial. Again, it becomes harder to see because your monomials are so lengthy, but this is still just one term. So this gets divided by that, and that gets divided by that. So split that up. Cancel what you can, which is the cosine betas of the first fraction, and the sine alphas of the second, and then cosine alpha over sine alpha. Cosine over sine is cotangent. Sine over cosine is tangent. And you are done. Without having to touch the other side. Any questions? Okay. This is going to be similar to stuff that we've done. You're given that sine of alpha is 1213 for a quadrant 2 angle. Draw. Okay. Always draw. Quadrant 2, so draw a triangle for quadrant 2. myself around what's going on here. So quadrant 2, right triangle, that's going to be your alpha. Opposite over hypotenuse, 12 over 13. So what's this? Yep. It would be 5 except for going left. So positive 5 would be this way. It would just be a negative 5. And I would say keep your eye on those positive and negatives as you're labeling, because that's going to make your life so much easier when you go to apply these formulas. Your beta is a first quadrant angle, and the sine of it, which is opposite over hypotenuse again, is 3 over 5. So what's this? Morgan, 4, good. And then part A and part B are definitely review. Cosine of alpha, just go to your alpha triangle, adjacent over hypotenuse. For the cosine of beta, just go to your beta triangle, adjacent over hypotenuse. And Aiden, this is why I said label that side with a negative 5, so you don't have to think about anything moving forward. Your signs will just take care of themselves. Okay? When we get to C and D, ooh. Oh boy. What she doesn't know is she was on video. Alright, so cosine alpha plus beta. So the cosine of alpha plus beta, you're just going to grab your formula. So from your formula, I don't want to keep flipping over, so I'm just going to write it down. Cosine alpha, cosine beta, minus sine alpha, sine beta. And then just start plugging in. From your triangle, or some of these we already did. Cosine alpha we already did, negative 5/13. Cosine beta we already did, 4/5. Minus sine alpha was given to us, 12/13. Sine beta was already given to us, 3/5. Truthfully, they're probably not going to walk you through part A and B in isolation. You're just going to jump right to a sum or difference formula. You're going to have to create your triangles and grab all that appropriate information and simplify it out. Does that make sense? Okay? So you'd simplify it out, you get negative 20 over 65 minus 36 over 65. Beautiful. And then the last one, which we can just start down below, a tangent one, just because we haven't done tangent yet. This is a subtraction. So I'm going to take my subtraction formula, so the tangent of alpha minus beta, and I'm going to do the tan of alpha minus the tan of beta and 1 plus on the bottom. So just using that formula, that's tan of x minus tan of pi over 4 over 1 plus tan x tan pi over 4. And that turns out very nicely because your tangents of pi over 4s just turn to 1s and you're done. That's a 1 and that's a 1. So you can evaluate whatever it is that you know. Tan x minus 1 over 1 plus tan x. Same thing. My order of addition is different in the denominator, but same thing. Okie doke. So this whole chapter is going to be just like a web of formulas. And I will warn you that as the days go by and you have more formulas to choose from, there's a decision-making process that you have to master. And like just kind of gut instincts that you have to develop, like what type of problem it is. Is it going to be a sum and difference formula one, or is it going to be, look at that reference sheet, any other of those categories of formulas. So in isolation, your homeworks might seem pretty easy, just using one set of formulas. But think about the review sheet and the test when you're going to have all these options and you're not going to know what type you're looking at. That's what gets tricky.